Good morning, HOD Professor A.K. Chaturvedi sir. My seminar guide Dr. S. Godar sir, seminar coordinator D. Sharma sir, faculty members, examiners, and my batchmates. I am Kartik Kumar, pursuing my BTech from University Department of Mechanical Engineering, Rajasthan Technical University, Kota, Rajasthan. My seminar topic is Advanced Fuel Material of Nuclear Power Plant. So, in this session, we cover these major topics. Introduction. The main motivation for the development of the thorium fuel is to be reduced fuel cycle that could be replacing thorium fuel, avoid the potential of the natural uranium shortage in the event of the rapid growth of the nuclear power. A nuclear reactor consumes certain specific gaseous isotopes to produce energy. The three most practical types of nuclear reactors are uranium-235 purified, that is enriched by using the amount of uranium-238 in natural mined uraniums, plutonium-239 transmuted from uranium-238 obtained from natural mined uranium, uranium-233 transmuted from thorium-232 derived from natural mined thorium. Thorium fuel cycle. The thorium fuel cycle is a nuclear fuel cycle that uses the isotopes of uranium-232 as the fertile material. In the reactor, thorium-232 is transmuted into the fissile artificial uranium-233 isotopes, which is the nuclear fuel. The thorium fuel cycle has serves potential advantages over a uranium fuel cycle. Thorium greater abundance, super physical and nuclear properties, better resistance to nuclear weapons. Plutonium and antineutrons production. Chain reaction of thorium. In the thorium cycle, fuel is formed when thorium-232 capture a neutron, whether in a fast reactor or thermal reactor, to become thorium-233. This is normally emits an electron and antineutron by beta decay to become plutonium-233. Then it emits another neutrons and electrons and antineutrons by a second beta decay to become uranium-233. Energy from thorium. Thorium itself will not split and release energy. Rather, when it is exposed to neutrons, it will be undergo a series of neutral chemical reactions until it eventually emerges as an isotopes of uranium called uranium-233, which is already to split, and they release energy next time it absorbs a neutrons. Thorium is called fertile and uranium-233 is called fissile. Need of thorium-based nuclear reactor and nuclear power. India is an expectation to the general trends. It has almost no domestic uranium resources. Only 1% of the world uranium resources are there. India's capacity to import enriched uranium fuel on the international market has been historically limited. However, India possesses relatively large amounts of uranium, and from the beginning of its nuclear program, it pursued the development of a thorium cycle that could be supplied ingeniously source fuel for the long-term nuclear program. Types of thorium-based reactor: heavy water reactors, high-temperature gas-cooled reactors, boiling water reactors, pressurized water reactor, fast neutron reactors, molten salt reactors, accelerated-driven reactors. Conclusion: thorium-based reactors are safer because the reaction can be easily stopped and the operation does not have to take place under extreme pressure. Compared to uranium reactor, thorium reactor produces less waste, and the waste is generated is much less radioactive and has short life. Thorium dioxide melts at 550 degree higher temperature than the traditional uranium oxide, so very high temperature are required to produce high quality advanced fuel. Any question?
Which state is the largest producer of thorium in India?
Okay, answer. Kerala is the largest producer of thorium in India. It is a radioactive and also found in Andhra Pradesh, West Bengal and Tamil Nadu.